Okay, I'm Mr. Lehman. This is the last video for this week. It's on finding the measures of arcs inside of circles. So here's a diagram. We have 3 different arcs being measured. I'm going to start with arc CD. Arc CD, I'm going to use my red pen, kind of highlight where that is. That's arc CD. We use 2 letters to show a minor arc, meaning that it's less than 180 degrees. And we say that the measure of the arc is the same as the measure of the the central angle. So 34 degrees is that central angle. So the measure of my arc is also 34 degrees. Next, I'm going to find arc BC. BC is this arc that's attached right next to, adjacent to arc CD. And that's going to be the measure of this angle inside here, angle BAC. That's its central angle. So that angle BAC and this angle 34 are supplementary angles. They make that linear pair. So we would say 180 minus 34 is equal to 146. So this 146 degrees is where this angle is in the center, which means that's also the measure of this arc, 146 degrees. Then define angle DBC. So DBC is using 3 letters to try to show you that it's a major angle. It also tells you the order to go. You go from D through B and end at C. So D all the way around through B and end at C. Since there are 360 degrees inside of a inside of a circle, 360 minus the 34 that's left. Basically, the green is the entire circle minus that red arc. So 360 minus the 34 is going to be, what, 326 degrees? So 326 degrees would be the measure of arc DBC. On this slide, you can pause and try to see if you can come up with the arc measures on your own. And then I'll pause my video and put in the answers, and then you can hit play and see if you got yours right. All right, so measure of arc DE is 90 degrees. Arc DE is right here. So that's just going to go with its central angle, so 90 degrees. EB, arc EB is highlighted in green. It's going to go with its central angle, 115. EC, EC is going to be from E all the way over to C, so going in blue. So that's this 115 plus 20 together is 135. DC, down at the bottom, is going to be the entire circle minus, or 360, right? 360 minus each of those. So 360 minus 90 minus 115 minus 20 is all 135, I believe. And then BDE, I'm going to clear off some of my measures here. BDE starts at B, it's a major arc, goes all the way around to E. So it's going to be this 20 plus the 90 plus the 135 we just had right here. So 20 plus 90 plus 135. It's like 100 plus 135 plus 10, so 245. And then the last one, BED, 115 plus 90. We get 205. So that's central angles and their arcs. The measure of an arc is always equal to the measure of its central angle. Okay, so after central angle, we talk about an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. Okay, this blue angle over here is an inscribed angle and contains a chord. The sides contain chords of the circle. It also has an intercepted arc. Okay, that's the arc that it intercepts. This is another graphic organizer. I highlighted in blue the inscribed angle. The inscribed angle goes all the way to the edge of the circle, and then it has an intercepted arc. What we want to do is we want to figure out how does the inscribed angle measure compare to the measure of the intercepted arc. So in class, I was going to have students go to Desmos and kind of create this, follow some steps and come up with a theorem. I'm going to try to do that now as well. So if I go to my browser, I type in geometry, Desmos, Okay, I can get this shape. I'm going to start with a circle, and then I want to make an intercepted arc and an inscribed angle. All right, let's see, I can hide this circle. Oh, I don't know what I did. Let's see. Just need to click on this and hide. I tried to do Control H, and that brought up like my history. Okay, and then I want to see if I can measure an angle. So choose a point, a vertex, another point, and so now I have this angle. So there's an angle shown on the graph. It's 22 degrees. I can make that bigger, smaller, etc. So right now it says 38. I also want to measure an arc. So choose a point, a middle point. So there's an arc. And then let's see if I can measure the arc. So to find the measure of the arc, we're going to first find the measure of the central angle, because that's what we've defined it as. So I'm going to go to my segment tool and actually find that. And then I'm going to change those colors. Because remember, the measure of the arc, okay, the arc in question, see if I can change the color of the arc. There, orange. The measure of the arc is the same as the measure of the central angle. So if I want to measure the angle, the central angle, right now it says 77 degrees. And as I change that arc around, it's going to change. So let me find a nice one, let's say 60. So 60 degree central angle, that means the measure of the arc is 60 degrees. And note, what is the measure of the inscribed angle? The inscribed angle is 30. If I do, let's see, 100 degrees, measure of my arc is 100 degrees, measure of my central angle is 50. I'm going to go to 22 degrees. If the measure of my central angle, which is the measure of my arc, is 22 degrees, then the measure of my inscribed angle is 11. So hopefully you can see, no matter where I go, I'm going to go back to 50 and 25. The measure of my center angle is always double the measure of the inscribed angle. Or another way to say that, the measure of the inscribed angle is always half the measure of the arc. So here's the theorem for that. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. And again, the way that we can find the measure of the intercepted arc, depending on the problem we're working on, is we can find the measure of the central angle that makes up that arc. So if I know the measure of angle C on the inside, that red angle, then that means I know the measure of the arc. And if I take half that arc, I can find the measure of angle B. So let's do a couple of practice problems with this theorem. Okay, so here's a 50-degree angle. This is an inscribed angle. That means that the measure of my arc is going to be double that, or 100 degrees. That also means that if I drew a central angle here, the measure of the central angle would also be 100 degrees. The measure of the inscribed angle is always half. If this is 112 degrees, then the measure of my arc is also 112 degrees. If I drew an inscribed angle from anywhere, doesn't matter where it is, then half of 112 degrees would be 50 plus 6, so 56 degrees. And it doesn't matter where this is. If this angle is exactly where it is right now, that's 56 degrees. If I drew another one, that's also 56 degrees because it intercepts the same arc. This arc is still being intercepted. So this AB arc is still 112 degrees, which means both of these inscribed angles are half, which would be 56 degrees. So if I have 66 degrees here, what would be the measure of my arc? It would be double 66 degrees. So 66 would be 60 and 60 is 120, 6 and 6 is 12, so 132 degrees. If I've wanted to find the measure of the central angle, central angle would also be 132 degrees. And it doesn't matter where it is, like this is a 75-degree angle, my arc AB is going to be double that, or 150 degrees. My central angle, if I drew a central angle, would also be 150 degrees. So that's the relationship between a central angle, an inscribed angle, and the intercepted arc.